आइए हम सुने विज्ञान की अनकही कहानियां.
Embark on a stellar journey with Dr. Joshi from the ARIES Institute as he unveils the mysteries of exoplanets and distant galaxies, revealing how this groundbreaking research not only expands our understanding of the universe but also holds the key to inspiring future scientists and enriching the lives of everyday people with the wonders of the space exploration.
I am Yogesh Joshi, working as a scientist here. I have been associated with the ARIES for past 27 years, I think. I did my PhD from this institute, and then I spent 5 years as a postdoc, first in TFR Bombay, and then 3 years in Queen's University Belfast in UK. And then I joined here in 2009 as a scientist. So though I work in several different fields, like open star cluster, gravitational lensing, and variable stars, but nowadays my main focus is on extrasolar planet, because this is one emerging field where everyone is interested. So everyone is thinking about, is there any alien, or is there any life in any planet? That kind of. So even the general layman is very curious about this thing. Everyone, even small kids ask. I mean, most of question when you go to school, I mean, these are on the alien life, space missions and habitability and all these things. So this is quite interesting field. Of course, right now in India we don't have that kind of capability actually, to explore this subject. But we are trying our best, and we are putting our effort, and in future we will have that kind of facilities for the next generation particularly. I mean, and they can really talk about the habitability, life, and all these things. Yeah, extrasolar planets, basically we have the planets around the sun. This is called solar system planets, and all that we have the 8 planets. So this is fine, but whether the planets are existing in other stars, so revolving around the other stars. So that is called extrasolar planets. So this is the new work. I mean, it has been started in the last 30 years. And first discovery of the planet had happened in 1995, but a major boost has actually that applied in 2009 when the space mission was launched. And a lot of discoveries in terms of thousands of discoveries had happened from 2012 when the data from the space mission came out. So, but anyway, ground-based observations are equally important for this kind of field. So basically, you are looking for the planet around the other star. So how you look? I mean, the directly looking the planet around the star is very difficult, because they are very far off objects. Planets are anyway faint. Even that's why we cannot see our own planets like Neptune planet, Neptune, and even the planet after the sun, Jupiter. So they are very faint objects. As they are away from their host star, less light falls on those planets, and they become fainter and fainter because they don't have their own source of energy. So same thing happens if there is a planet around the other star and the whole star planet system is quite far off. So the light coming from the planet is very, very faint. So this is very difficult to image those planets direct. This is called direct imaging method. But there are cases, I mean, where the big telescope, adaptive optics are used to discover this planet. But their number are very few, 40-50 number of planets through the direct imaging method. Then people started looking for the alternative method. Though we cannot see the image of the planet, but can we infer is there any planet in the system? So then this transit method and radial velocity method, are discovered. Transit method basically, as even the solar system, there is this Venus transit or Mercury transit. So any planet revolving around the sun, and if it falls, it crosses the disk of the sun. So there is always this black dots. So means the planet is passing across the disk of the star. So when that black dot happens or the planet is passing, so light from the host star is not coming to us, not reaching to us, photon from that area, that particular area. So it means there is some dimness, the decrease in the brightness. So during that period when that transit happens, as it happens in our case like Venus transit and Mercury, as I tell, so then there is slightly decrease in the light, and it decreases the light depends what the size. If it is big planet, big size, so it will block more light, so more deep, more reduced in the brightness. And if there is less small planet, so it will reduce small amount of flux. So it means that size, which is dictated by the size of the planet, will dictate how much brightness fall or brightness variation is there. So now whether we can really see that variation, that change in the brightness, the fall in the brightness due to the transit, due to the planet revolving around the star. So naked eye is not possible, because if suppose a Jupiter is passing across the disk of the sun, there is just change of 1% brightness variation, and through the naked eye we cannot observe that 1% variation. But with the telescope we can, even 1 meter telescope, that 1% flux variation, which is equivalent to almost 10 millimeg variation. So with a 1 meter telescope we can detect that variation. So telescope can, it means 1 meter class telescope can actually detect a Jupiter around a some kind of star. But if it is a planet is small size, like Earth size planet, for Venus size, Mars, that kind of planet, so then it is difficult. Then you have to go to space to see 0.1% flux variation or 0.01% flux variation, that kind of variation. So then we have to go to space, and using this transit method they can detect even the small 0.1% variation, 0.01% variation, and we can detect planets. So it means small size planet are normally discovered from the space. And other method is radial velocity method. So if the star is revolving, the planet is revolving around the star, so star is also revolving around that very center of mass. So it is like two body system. You have a one massive object and you have a small mass object, and both are revolving around a common center of mass. So now if it is more massive planet, the orbital radius of that star revolving around the center of mass will be larger. So what will happen? You will see that movement, that is called wobbling method. Now it is, if this wobbling is like star going away from you, coming towards you, going away from you, coming towards you, you will see this variation in spectroscopic observations. There are characteristic lines of a star. So when you observe through the spectrograph, that line will go left side, right side, left side, right, depending upon it is blue shifted or red shifted. So if your instrument is sensitive enough to detect that variation, that movement of those lines, then you can detect a planet. So again, a Jupiter sized planet around a star, sun like star, is easier to detect because the variation is significant enough. But small size Earth mass planet, it is difficult. The variation of that lines are very, very small. Then again you need very sophisticated instrument to detect that small variation. So therefore this high resolution spectrograph particularly are very useful, because they can really see the small variation around this central line. So for the small size planet, small mass planet, of course if it is small mass then small size there, so both are associated. So these small mass planet, you need very high resolution spectroscopy to detect these planets. So this kind of work is also going on, but this transit method you can do from the space also, so that's why it is more successful. So thousands of planets are discovered, but for the high resolution spectrograph there are very limited high resolution spectrograph. Even in India there are just 2 high resolution spectrograph. So that's why less number of planets are discovered using this method. But I mean, there is this curiosity. I mean, everyone wants to know there is planet, there is life, and there is biosignature in the atmosphere of the planet. So this curiosity of having the biosignature, if there is living organisms there, or there is some kind of indirect signature of the life, even this algae, for example, if that is there. So this, if we can study around these nearby planets, this is very helpful to understand the whether life exists elsewhere other than our own Earth. So right now Earth is the only place. Among 10 to the power 11 stars, there are 100 billion stars in our galaxy, and there are 100 billion galaxies. So there is huge number, 10 to the power 22 number. So and Earth is the only planet where life is there. So there is great focus that if there is any life around other star, other planet, so that is main focus. And once we know the planet, now we have the more than 5,800 planets discovered so far. So we are trying to understand atmosphere of those planets, And now there are some exoplanets which are like habitable one, where the life can exist, or where the liquid water can exist. And now scientists are looking for the habitable planet where any sort of life, that biosignature, what we call, can exist or not. So that is the main goal, and this is, even the common layman point of view, this is very useful. I mean, because everyone think whether we are alone in this universe. Well, even the curiosity about this alien life, people often think that whatever they show in the TV or these movies, whether it really exists or not, because the general impression, if you keep on showing them these aliens and different planets, they always think, okay, it is exist, but actually scientifically it is not proven. So, but we are focusing on this direction and trying to find some kind of alien life, or even the macrobiological kind of life. As I have told, I have done work on different fields. I started my PhD in graphosmic lensing event, and started looking for variable star, different kind of variable star. Then during my postdoc, first postdoc, I studied the star clusters. Then for my second postdoc, I started looking for the new extrasolar planet around the star. So we are trying to discover planets using the ground-based observation. In fact, I led one paper in discovering the planet, that is West 14b. So we have discovered this planet, and I led that work. And then after returning back to India and joining here at ARIES in 2009, I had started working on the extrasolar planet, but other fields like star cluster, because for the detection of the extrasolar planet, you need very sophisticated instrument, very highly sensitive instrument, which we didn't have at that time. We have just 1 meter telescope, 1.3 meter telescope. So you need big size telescope. You need very high precision photometric observation. You need very high resolution spectrograph, where you can detect really very small variation in your chemical lines. So you need all these things. So not much work has been done in the extrasolar planet field using this small facility, but we are hopeful that in future we will have, because even the ARIES is going to have a new horizon spectrograph next year, and now one new one have come in the PRL telescope in Mount Abu, and of course we have one in the Henley also. So in future, I think this field will emerge, and on top of that, India is also planning to have one space mission, and right now we are in making the proposal. It is going to ISRO and the will government. So it will take time, but the initial work is already done. So what kind of telescope we are planning, and what should be wavelength range, that basic specification are already frozen. So things are progressing, but it will take time, few years. So in future, if everything goes well, we may have the telescope for this exoplanet work in the space, Indian telescope. Of course, US is leading this work because they have all these space missions, they have the big telescope, they have bigger community. Like our community is maybe 700 people, 800 people in India, but they have more than 3,000 scientists in US. So they have big infrastructure, NASA is there, they have all the expertise, and all these big missions, whether it's Kepler space mission, JWST mission, even the future habitable world observatory. So all these missions are sent by the NASA, or even future mission like habitable observatory. So they are being planned by the NASA. So of course US is leading this work, but our community in India is growing, because many students who did their PhD or even postdoc abroad in this field, they are coming back. So few years back, if you see, there are not many people working on the exoplanet. There were a few working theoretically, and we didn't have much observation expertise. But now a lot of students who are now faculty in various places, various IITs, ICERs and teaching institutes, so they have started working on extrasolar planet, and they are collaborating. They are using our facilities also. So in future, this field will emerge in India also. And once we have this space mission, as I told earlier. So then this field will really grow in large size in India. I mean, I think India can have an impact. DST is doing an excellent effort. First thing is that, I mean, whatever we publish, I mean, whatever we do work inside our rooms, now DST want that it should be, advertised, it should be published in a newspaper, even the various platform like even Facebook, Twitter, I mean, just keep on, and even through this podcast also. So DST is doing a tremendous effort, as well as DST is spending a lot of money, I mean, in big project like even TMT, I mean, it is put a lot of money in that project. And of course, this mission, which I am talking about, the space mission, government DST will support, but it is a big mission. I mean, we are talking about few thousand crore rupee. So government will may sponsor this one. So, and initiative to reach the layman, common people through these various programs. And I think in recent times DST has taken great initiatives. And now even the students, young students, common people, they are, being encouraged in the field of science. They are asking a lot of questions. We have, visits where we communicate with these students. Even we go to various schools, and there are so much interest among the students. I mean, they really keep on asking so many questions. Even you have a 1 hour talk for next 1 hour or one more, they keep on asking various questions. So I think in that sense, this field is quite emerging, and in general the science among the youth, among the small kids, and this is taking a new heights. And future, I think it will be even go further, because the science, I mean, these kind of topics which we have studied during your masters and PhD, nowadays even 5th standard students are understanding or reading through the online channels, online platforms, as well as something is in their book also.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.